friends, welcome to my channel Explore with Joyita.
Isaac Newton made a conceptual breakthrough by recognizing two different kinds of motion, uniform and accelerating. He defined force as any phenomenon that causes an object to accelerate and applied this definition to his own studies of gravity, describing it as an attractive force that exists between any two masses anywhere in the universe. Newton's law of gravitation states that any particle of matter in the universe attracts any other with a force varying directly as the product of the masses and inversely as the square of the distance between them. Anything that has mass also has gravity. Objects with more mass have more gravity. Gravity also gets weaker with distance. So the closer the objects are to each other, the stronger their gravitational pull is. Isaac Newton put forward the law in 1687 and used it to explain the observed motion of the planets and their moons, which had been reduced to mathematical form by Johannes Kepler early in the 17th century. The whole discovery was occasioned by the fall of an apple. The young Isaac was sitting in the garden thinking about the universe and how it worked and pondering about the difference between apple and the moon. The apple falls but the moon does not. He tried to discover the mystery behind this issue and finally he found the answer. Here is the gist of Newton's idea. When the apple breaks loose, it falls to earth straight down. But if someone picks up that apple and throws it sideways with a certain amount of horizontal velocity, as Galileo said, the apple adopts a parabolic path. The harder the apple is thrown, the more horizontal distance it adopts and the farther it goes. What Newton realized is that if the apple is thrown hard enough, it would go into an orbit. It would continuously fall, but as it fell, it would move around horizontally, and it would keep going around the earth. That's what the moon is doing, is going around the earth, constantly falling, but it has sufficient horizontal velocity to keep it in orbit. The same thing happens with any planet, with any moon, anything that is orbiting the sun, anything that is orbiting the earth. Uranus, the seventh planet from the Sun, has the third largest diameter in our solar system. It was the first planet found with the aid of a telescope. Uranus was discovered in 1781 by astronomer William Herschel, although he originally thought it was either a comet or a star. It was 2 years later that the object was universally accepted as a new planet, in part because of observations by astronomer Johann Elert Bode. Herschel tried unsuccessfully to name his discovery Georgium Sidus after King George III. Instead, the scientific community accepted Bode's suggestion to name it Uranus, the Greek god of sky, as suggested by Bode. With the 1781 discovery of Uranus, the number of known planets in the solar system grew to 7. As astronomers continued to observe the newly discovered planet, they noticed irregularities in its orbit that Newton's law of universal gravitation could not fully explain. The new planet's orbit obstinately refused to follow the path mathematicians insisted it should, pointing to another hidden planet lurking beyond. Before 1821, Uranus appeared to be moving faster than it should have been, based on the known bodies near it. But within a few years, it appeared to be moving too slowly. Over the years, the nagging difficulty of explaining the future path of Uranus only got worse. Eventually, two mathematical astronomers began to investigate. In 1845, astronomers Urbain Le Verrier in Paris and John Couch Adams in Cambridge separately began calculations to determine the nature and position of such a planet. One of the first to study the irregularities in Uranus' orbit was John Adams, who was an undergraduate when he first learned about them. After finishing his degree, he got elected as a fellow of his college and he started studying the problem deeply. By September 1845, he completed a lot of calculations. Still, they were not recognized at their real value, and his conclusions were doubted. Urbain Le Verrier, unaware of Adams' research, began one of his own, concluding with the presentation of his work at the Academy of Sciences on November 10, 1945. His work sparked an interest in the British scientists, who immediately recognized the similarity between Adams and Le Verrier's studies. Adams' work, previously seen as a scientific curiosity, was now declared an urgent subject for observation. As Le Verrier couldn't get the attention of the French scientists, he sent his results to the Berlin Observatory. Johann Gottfried Galle, a scientist from Berlin, received Le Verrier's letter on 23 September and immediately set to work on the problem. The discovery came very fast. Just after midnight on September 24, 1846, Galle saw Neptune following Le Verrier's calculation. Hence, Neptune became the first planet to be discovered by using mathematics. The Royal Society awarded Le Verrier the Copley Medal in 1846 for his achievement and also awarded Adams the Copley Medal in 1848. Neptune has been observed many times before 1846, but it was always overlooked. John Herschel almost discovered it the same way his father, William Herschel, discovered Uranus. Still, it was not regarded as a planet. It was all the time mistook with a star. Indeed, there is evidence to show that Galileo identified something strange about the blue dot in the sky. He was aware of the fact that he had discovered something unusual about Neptune, but did not have enough data to continue the research on the subject, and so he never came back to the problem again. On October 10, 1846, just 17 days after the discovery of Neptune, astronomer William Lassell discovered a moon orbiting around the planet using a self-built telescope. A second moon was discovered in 1949 and a third moon was discovered in 1981. Due to its remoteness, about 30 times as far from the Sun as the Earth, much about Neptune remained a mystery beyond some basic information. Astronomers knew that Neptune was the fourth largest planet in the solar system, and like other gas giants, its atmosphere was composed primarily of hydrogen and helium. Temperatures at its cloud tops were estimated at around 55 Kelvin or minus 361 degrees Fahrenheit. Neptune's day was estimated at around 16 hours. On August 25, 1989, passing about 3,408 miles above Neptune's north pole, Voyager 2 made its closest approach to any planet since leaving Earth in 1977. During its 4-month observation period, the spacecraft returned more than 9,000 photographs of the planet, its moons, and its rings, and returned a wealth of scientific information. Voyager 2 imaged a large storm called the Great Dark Spot and clouds in the planet's upper atmosphere. On the 840-mile wide moon, Triton, the spacecraft observed clouds and hazes and its atmosphere and revealed geyser-like features with its polar cap. Voyager 2 also discovered 5 additional inner moons and confirmed that a set of dark rings encircled the planet. 5 more small moons were discovered using a large ground-based telescope in 2001, and a 14th moon was identified in 2013 in images from the Hubble Space Telescope taken in 2009.